Hello everyone, I'm with a new video. As I said in my previous video, I will show how to calculate your HOMO-LUMO orbital by using two different software. One is Avogadro software and Gaussian software to calculate molecular geometry and their HOMO-LUMO energy and visualization. So if you see here the HOMO of this molecule and HOMO of this molecule, so what are the things you need to know and what are the things you need to install before you start calculation. So the first thing is Avogadro software. It is a free software, free cross-platform molecular editor. I'll show how to use that, how to download this, and how to start molecular making molecule. And once you make this, and from there you have to make the molecular coordination, and after that you have to run the calculation through Gaussian 16 software or like Gaussian 9. I have the Gaussian 9 in my PC installed, but nowadays many people might have access in the cluster computer in your university, so you can use the cluster computer to use the Gaussian 16. And once your job is done with this software's calculation job is done, then you can see or visualize your molecular HOMO-LUMO or like spin density things by GaussView. So you can go to Google and type Avogadro software. So you will see this, and Avogadro free cross-platform molecular editor Avogadro. So get Avogadro. You can click here and then you can download it. Download here, and or there are couple of version might have. So I already downloaded one of these. So once you download, then install it in your computer, then you will get the Avogadro. And once you install it Avogadro, so you will get it in your computer. So you can open this. So there are a couple of things you need to know. There are things you can play with to see the molecules. You can get cartoon, dipole, force, hydrogen bond, label, polygon, different things. I will show how this works. First of all, you need to know those icon. Here is the pencil icon. So with this you can draw the molecule. You can rotate the molecule. This is also like 90-degree rotation, and it is like selected, like you can select a specific atom, and with this arrow you can choose a certain, like with this suppose you use this arrow, so you can choose the whole molecule, like select this molecule, and if you do again, the molecule will be selected, and then you can use this finger by rotate the whole molecule from one place to another place, and with 90-degree, so you can rotate one single bond like this, and with this you can rotate the whole molecule in different orientation with the three-dimensionally, and with this arrow, so you can control different rotation, so it will be rotated automatically like this, and if you click it there again, so it will be stopped. And this is like E down, that means it will make your lowest energy stable molecules. If you click it here, it will make automatic lowest energy, like you have to do start here. But normally I don't do this here, I will do another place. So just click again, so it will be gone. And then, so these buttons are important. So first of all, um, let's select the whole molecule, delete it with the delete button. Now when you click in the pencil, you will see element here in this left hand side, the carbon bond order single adjust hydrogen. So I will take out the hydrogen out first, and carbon is there. So with this pencil, if you click on this whiteboard, then one carbon will be there. Now suppose I want to draw a benzene ring, so make a like hexagonal shape ring, and then click on the one single bond, then it will be automatic double, and make alternative double bond like this. Now I want to make a 5-member ring here like this, and then another benzene ring here. Basically I'm drawing the fluorine molecule, and suppose you want to put 2 methyl groups, so all carbon means like carbon, here no hydrogen is there. Now here I want to put a nitrogen here, but it is black like carbon. So if you want to put nitrogen, go to the element, select nitrogen, and then click on that carbon, it will automatically convert to nitrogen. And then again make carbon, and then you will get like this, and that, and that, and double bond. So I want to make it acetate group, so it should be oxygen. So I will go here and select oxygen and click on this, so it will be converted to oxygen. So now you have nitrogen, you have oxygen double bonded carbon, and it will be methyl, and all other carbon should have one hydrogen. You don't need to worry about those. So first draw the molecule, then go to the extension here, extension, and do optimize geometry. So it will optimize geometry like according to Avogadro. So you can do one more time, optimize geometry, so it will do like that. So now you can rotate by using this, rotate the molecule, so you can see how it is rotating, like how it looks like. Now you can put the hydrogen in the whole molecule. So how you can do this, go to build, and then add hydrogen, click add hydrogen, then you will see all carbon or like any other atom which should have hydrogen, it will automatically take hydrogen on that. Then go to extension again, do the optimized geometry again. So after addition of the hydrogen, your geometry should be optimized again. So do 1 or 2 times, then it will be optimized. So this is the Avogadro software. It is very nice and important tool to do that. Now these things you don't need to do anything if you want to do the calculation, but you can play around if you select these. So dipole moment, where is the dipole moment direction? So you can see this dipole moment direction is this way for this whole molecule. So any molecule you can find out where is the dipole moment should go, like what is the direction. And force, if you click force, so all of the things will not give, may not give you the hydrogen bond, may not give you the information label. So if you label it, so you'll see like different number of hydrogen and carbon number. And polygon, so it is not showing the polygon. Ribbon, no. Then ring, if you click ring, so it will show different ring with the different color. And simple wireframe, no. And stick, if you click stick, so it will show like a stick structure like this. And then surface, so surface is not here. Van der Waals force, so you will see this molecule. You might have seen this kind of molecule in many organic chemistry textbook. So how it looks like Van der Waals spheres. So you can see some idea about the space between the atoms in the molecule. And wireframe, wireframe. So in that case, you have to remove this. You have to remove stick, So you will see ball and sticks, like all take out all those, like just wireframe, so you will see only the wireframe for the molecule. So now normally just use the ball and axis, and in that case you don't need to use the wireframe. So here this is the molecule. Now if I want to calculate the geometry optimization by the Gaussian, so you can go the extension here, and there are like couple of options here. GAMESS, this is the one software. Evinit, Dalton, GAMES UK, Gaussian, MolPro, Mopec, NWCam, PSI4, QCam, LAMMPS, Molecular Orbital, ORCA, and QTAIM. So there are many different software to do those calculations. So nowadays people also using Orca a lot. Orca is also popular, and probably in my another video I will try to show some similar kind of calculation by using Orca or Mopec or MolPro. But today I'm going to show you the Gaussian. So just click Gaussian here. So if you click Gaussian, so you will see this kind of window. So in that case, put title. So suppose I am putting experiment 1 or something like this. Then click here. It is already selected geometry optimization. Sometimes it may be single point energy or frequency, but click geometry optimization. Processors 1, B3 LYP, that is theory, and basis set should be 631 GD. There are some other options, but select this one, GD. Charge should be 0 since this is a neutral molecule. Multiplicity should be 1. Output standard, and checkpoint you don't need to checkpoint. Cartesian coordinate, and nothing else. So once you make these, just click generate. So if you click generate, so it will ask you the place where you want to generate. So you may choose desktop or like any other place. So if I select desktop, so put experiment 1 and then click save. So that will be like, see here, experiment1.com. so it will save as a output input file. So it will be like Gaussian input file. So just save it. It will save. I already made one, so it is saying like already exists. Do you want to replace it? I'm clicking no, but you will click yes. Like you don't need to have this, because if you make it first time, so it will not show like it already exists. So once you click save, then it will be saved. So in that case, still you will see this in your here, so you can close it. Then Avogadro part is done. So basically this software will make you allow you to draw the molecule, to do the optimization according to this software, and finally build the molecule with the hydrogen and do the optimization again, and go to the extension again and make click the Gaussian, and then you will see that window, and just what I did, you can follow that part. So once it is done, and then just so suppose my experiment 1 is done here. Now I will double click the Gaussian line. I'm doing the data here. So Gaussian is opening. Now here click file, click open, and then from the desktop you can see where is that input file. You may not see here. Click here in this place and click all files. So once you click all file, then you will see experiment 1 like this. So click exp1 input file, then click open. Once it is open, so you don't need to do anything here. Just click here B3LYP631GD and okay. So one thing you might see, uh, since I already checked this, that's why it is showing this. So you might see like this, like B3, once you open for the first time, then you'll see like this, the same thing, OPT. So click here with the bracket, then make a space, then click pop, POP. First P should be capital, pop, then equal to, no space, then small REG, then space, then capital F, form, FORM, then capital C, no space, CHECK, form check. So pop equal to REG space form, FORM, CHECK, then in between OPT and check there should be only one space. Okay, so once it is done, and the title, you can put the title as experiment 1. All other things would be same, so you don't need to do anything. And this is the start button, either this or this, anyone. If you click, it will start calculating. So if I click here, but remember, if you make mistake here, then the software will not take your calculation. So remember, just you might see up to D, then OPT, but so you have to put a little bit extra thing here, pop equal to reg space form check space OPT. Then once it is done, click this, then it it will show ready for processing start. So in that case, it will ask you where to save your output file after calculation. So here it will show you automatically to your Gaussian software where you install, and it should be in the C drive and Gaussian file, and then you, whatever the name you want to put, you'll save like that. But normally I do save in the desktop. Suppose I want to get as a like this, like whatever the output name I want. So I will start, like I will click save, then you can see it will start calculating. So this is saying z09.exe is a processing, so it will it already started calculating. And then it will take some time to do all the calculation, and you will see here the processing. So once this processing is going on, then just wait until you will see here the processing is complete. And in bottom here, now it is saying um, solving the self consistent field equation. And also sometimes you will see some other execution what it is doing, and at the end it will say finalizing the calculation. I'm sorry, finalizing the calculation. So once that state is there, like finalizing the calculation, and you will see here basically like run progress, you will see like processing is complete. So once it is done, then you will you can finish your work. So click here. Okay, now you can see the software is showing processing complete, and here it's showing finalizing calculation and output. So that means this process is complete. And you can see here all those calculations, energy values, and there are lots of data here, so you can use those data to see like using calculation and output. So you can close this one, click here, then it will ask you, notice change of this not been saved. Save before exiting. You can say yes. You can do only when you see processing complete. So click yes, and then it says these usernames already exist. Overwrite it. You can click yes. So in that case, you will see this file, as I said, experiment 1 _ 1. So this file can be opened by the Avogadro to see that, also by GaussView. So here I have GaussView 5 and GaussView 6. So I can double click in the GaussView, and it will show Gaussian is not installed. It's okay. um, it's it's showing different thing. I can click OK. Now it will open automatically, and there's something like this. You can click close. So once it is done, you can just drag this molecule here, and you'll see the molecule here. And once this molecule here, you can see this orbital shape, blue and red, like this dumbbell. So you can click on this dumbbell, then you'll see another window like this. So here you will see all the state and electronic state. So those are like for the whole molecule, those are occupied orbital, and so it is going energy up. So this will be like HOMO, like highest in energy, occupied occupied orbital having 2 electron, and next to it will be LUMO. So this is unoccupied, and energetically it is the lowest. So lowest unoccupied molecular orbital. So here once it is open, so what you can do, just you don't need to change anything. Charge 0, spin singlet, Gaussian amos from experiment that one. So you can go new Gaussian molecular orbital. So generate using Gaussian, like you don't need to change anything, just click generate. So it will show something like this. Then just give it time to do the processing. Once it is done, processing complete, then click yes. It says Gaussian job has completed. Do you want to close the Gaussian window? You can say yes. So once it is done, then you can see your HOMO and LUMO. How? These two are yellow. So bottom yellow is HOMO and this one is LUMO. So click on one of, like click both of them, yellow is gone. So click one is this, like here, like 67. Then click visualize. So once it shows like ISO value is 0.02, and cube grid cores, or like you can keep cores or medium, whatever. You don't need to change anything else. Just click update and wait. Then you'll see the you can make the bigger while it is updating. So I click update and I'm waiting for that. So once it is updated, so you can see the HOMO shape of this molecule. So you can rotate by this. So this is the HOMO of this molecule. Now if you want to see the LUMO, so click here and click one, like just this, and you can click update again. So it will take a little bit time, couple of seconds, so it will be changed to its LUMO shape. So it changed to LUMO. So it is looks like LUMO is different than the HOMO. So these two, and probably these are the energy value. And if you go one down from the HOMO, that is called HOMO -1. So you can click it, HOMO -1, and then you can do update, then it will be changed. I'm waiting to see the change. So this is HOMO -1 for this molecule. So, and you can do like HOMO -2, HOMO -3, HOMO -4, but sometimes people use HOMO -1 for the transition, to detect the transition of UV spectroscopy or like for fluorescence spectroscopy. So similarly, for the LUMO and above 1, that could be LUMO +1. So sometimes they shows that what could be the transition from HOMO -1 to LUMO, HOMO -1 to LUMO +1, or HOMO to LUMO +1, something like this. So let's see how it shows LUMO +1. So once you select this, you can click update. So actually you can see all of those by selecting one, clicking update. Once it is updated, then you can see those box is created. So this is LUMO +1 shape. So you can see how LUMO +1 is showing for this molecule. So once those boxes created, so you don't need to select and do update again. So that means it is already updated, so you just can click on this box, then accordingly it will be changed. So here it is HOMO, it is HOMO -1, HOMO again, LUMO, and LUMO +1. So this is the way you can see the HOMO-LUMO thing. So now how you can transfer this figure in Word file or like PowerPoint. So it has, you can rotate it any orientation you want to show, how it is showing, like this, or that, or any orientation, any direction. So once you see like suitable direction, then on this board you can click right mouse, go to file, and save image file. So if you click here, first go here, background color is like blue color. If you want it as a like colorless, like white color, then click OK, and then go to here, and file name is this, and directory is username desktop. So if you want to change the position, then first change the position, then go to the here and change the color, because if you change the position of this place, double click, so do this double click and change it like where you can save like desktop or any other folder, then what will be the name, so you can click like as a save. And once you change it, so in that case it sometimes may change the color. So just click again here and go to this white color and click so click save, so it will be saving in the desktop. So here you can see this one in the desktop. So here if you double click it, you can see open it, or you can directly copy the full version, like copy it and make a Word file, and then click it right mouse, and you will get this picture. So then you can crop it to smaller according to your size requirement. Then you can do a smaller version, and also you can small the size or like bigger the size, whatever you want. So this is the one you can do like with the Gauss view and take the molecular orbital picture like this. Now, so suppose if you came out from here, but still your molecule is there, and if you lost that window, then you can click again in this dumbbell, like orbital dumbbell here. So if you click it, you will see the same window again. So from here, if you want to take the other orbital picture, you can take it back in like right, you can click right mouse, file, you can do print or like save image file, and make sure that file save option, you go there and change the color, background color. I normally prefer white, so click OK and click save, and then it will be saved. Since I already saved one name, so that's why it is saying overwrite it or not, because in that case you can say save as like the exp1 underscore 1 underscore lumo, so the name will be changed or different. So I hope you, and before I going, this was the simple technique to do the calculation, like very normal method or simple method. But in some cases people do more complicated calculation. In that case the command, after making the coordination with the Avogadro, so whatever the coordinate file we made for the Avogadro, suppose for this, what was the output file, so experiment, like experiment 1, so you can click here and then you can open, show more options, and you can edit with notepad, and you can see like this command. So in some cases people also do more command, adding more command. I can show you one sample. Let me check. um, okay. So here, like, open this with the notepad share, so you can see percent n pro shared equal to 8, percent chk equal to, then you always need to change this name, like your molecule name dot chk. So molecule name means like whatever the title you are using. Suppose I used experiment 1 underscore 1, so, or like experiment 1, it was, I saved like this, and percent memory 16 GB, p blyp iop, like there are some conditions here, and opt like tight, cal cfc, no symmetric, scrf equal to pcm, solvent equal to dichloromethane, normally people use as a solvent dichloromethane, and SCF equal to Fermi, XQC, max CYC equal to 200, and this. So the whatever the coordinate you get, that is from this part only, like this part from the Avogadro part. But additionally you have to add this here, and also you have to add like link and the similar, but here again you have to change the name, like exp1 dot chk, and all other thing will be same, and here also like percent check, that will be like exp1, and once it is done, like like add those as a link just under the coordination one you get from the so this is actually for the cluster computer, Gaussian 16 running, or like 9 right running, whatever. But if you want to do the cluster computer, so just copy this part, and we already open another notepad. Where is that? Or like whatever you make from the Gaussian. So show more option, close, show more options, and edit with notepad. So here you will click here and paste like this, and make a space, and at the bottom, so go, where is the other one? Okay, so feel like you have to wait, open every time, so just copy and paste. So top part I copied here, and the bottom part also, like with the link. So I'll just go here, and that two part I will copy it, and then I'm gonna save it. So once I save, then it will be saved as like this, and that will be ready to run in the cluster computer. So like supercomputer, which are like common in the big universities. So the thing is, these will be like very specific conditions, like people do, like they have those commands to check different values. And also there's some paper, um, if you want to see any paper, like suppose which paper I can show you. So there are many paper you can see. If you want to see more paper link, who be like where people do the computational chemistry, so you can read those paper, go through that, and there are like a couple of basis set they put during the calculation. Also they put some um, the conditions. So let's see here one of the paper. So let's go its original, and like go to the supplement. So this paper has some DFT calculations. So whatever the very, like I showed how to calculate the HOMO-LUMO, that is very basic simple DFT. But for like complex DFT, people also do those methods. So MN15 CAM BLYP D3BJ B3LYP D3BJ PBE0 D3BJ. So those calculation also can be found, and there are different books, computational chemistry or like journal. So here this DFT is used like 631 plus G star star plus PCM, like solvent is CH2, like dichloromethane level. So if you want to know about those, you can look for the different journal or like books, then you will get like how those things are implied in the coordinate page. So here these commands, and also like in the bottom, like those are like the links, those will improve your conditions. So today that's it, and I hope you have learned at least how to calculate the geometry and the HOMO-LUMO, and you can get the information from the different software actually you can do. So uh, when you want to see any energy value like calculation, diagram, or any energy value, from here you can see or find those things. So if you like my video, just give a like, and also if you have any question, I am not a computational or theoretical chemist, but whatever I know I just try to show here. But if you are more interested, then you can ask me, I can give you some paper link and you can go through those papers. And who didn't subscribe my channel yet, please do it, and who already have subscribed, thank you very much. And until next video, stay fine. Bye now.